Continuing to work with the elimination method in solving a system, we are going to come across some problems here where we're going to have to multiply by a number to create opposite coefficients. So again, remember, the whole idea of the elimination method is to have opposite coefficients so that when we add the equations, one of the variables is eliminated. So let's go through our steps here and we'll take a look at what we have to do here. So in solving this system, we look and all the equations need to be in standard form, which they are. We then look for opposite coefficients. So -3 and -2 of the x's are not opposites. 9 and -3 are not opposites. So we don't have opposite coefficients to begin with. We don't have the same number like we had in the last one, so we just needed to multiply by -1. So in these examples, we're going to need to multiply by a number that creates opposites. And what you're going to run into here, what you want to look for are numbers that are multiples of each other. In other words, if you're counting by twos, 2, 4, 6, 8, 10, all of those numbers are multiples of 2 because they're all divisible by 2. So when you're looking in this lesson, you want to look for things that can be opposites, one that's a multiple of the other. So again, that may sound kind of convoluted a little bit, but let's take a look at what I'm talking about and maybe an example will clear that up. If we take a look at the x values, if we counted by threes, 3, 6, 9, 12, 2 is not a multiple of 3. So we don't want to do anything with that number. If we take a look at 2 and we count by twos, 2, 4, 6, 8, 3 is not a multiple of 2. So multiplying by a single number is not going to create opposites in that for those two. If we take a look at our y variables, the number 3 here, 3, 6, 9, 9 is a multiple of 3. So all I have to do is multiply this 3 by a number that will give me 9, multiplying by 3. And because the signs are already opposites, all I need to do is to multiply this second equation by the number 3. Because if I multiply this by 3, I'm going to have a -9y, which is the opposite of +9y. So because 9 is a multiple of 3, I just need to multiply this one equation by the number 3 to create my opposites. Okay? So if we don't have opposites to begin with, and we don't have the ability to multiply just by a negative sign to change the sign, next thing we want to look for is multiples. Alright, so we're going to multiply this second equation by 3. So because I'm changing the second equation and I'm going to need to add this new equation to the first one, I'm going to go ahead and rewrite this first equation down here below it because I'm not changing this at all, but I am going to have to add to it once I multiply. So multiplying by this 3 now, I have 3 times -2, excuse me, which is -6. 3 times -3 is -9. There's the opposites that I wanted. And then 3 times 11 is 33. So I now can create or have created opposites, so I can go ahead and add these two new equations together to eliminate that y variable. So -3 and -6 is -9x. 9 and -9y is 0. And then I have 33 plus 3, which is 36. I now have eliminated the y variable because I created opposites, and now I can solve for the x. So solving for the x, I'm going to multiply by the reciprocal of -9, which is dividing by -9. And so the -9's, So the -9's here are going to reduce to 1. 1 times x is x. Then this 9 reduces to 36, leaving 4, and 4 times -1 is -4. So the x value of my solution is -4. And now, just like always, we can go back to the original two equations or the new equation that I created, substitute in the value for x to figure out or determine the y value. I see a lot of negatives, so nothing's going to be really easy, so I'm just going to go right back to this first equation and substitute into that one. So everywhere I see the letter x, I'm going to substitute in the -4. So -3 times the -4 then, plus the 9y is equal to 3. I now have an equation with just the letter y, so I can determine its value. These two multiplied together are +12. I then am going to subtract this 12 from both sides. Let's see. I know you maybe can't see that green very well. I won't use that color again. So that's equals 0, so I have 9y, and then 3 minus 12 is negative 9. I then am going to divide by 9, or multiply by its reciprocal, because that's what division is. So the 9's reduced to 1, leaving me 1 times y, and the 9's reduced here to 1, leaving me negative 1. So my y value of my solution is a negative 1. So in this problem, again, just remember the concept. We just need to create opposites, and we can create opposites by multiplying by a single number. And in this case, what you want to look for are multiples, so that you can multiply one equation by one number, creating the opposites that we need. Looking at number 3 on our worksheet, we are again going to follow our steps. So we're going to look and make sure our equations are in standard form, which they are. We're going to look for opposites. 2 and 6 for the x's are not opposites. 5 and 10 are not opposites either. So I want to look for a number that I can multiply by in order to create opposites. Now I've got a couple of options here. Because 6 is a multiple of 2, I could multiply this first equation by a negative 3 to create a negative 6, which would be opposites. If I look at the y coefficients, I could 10 is a multiple of 5, so I could multiply this first equation by a negative 2, because then the negative 2 times the negative 5 would give me a positive 10, which would create opposites as well. So in this particular case, I have options, so you just choose whichever one you would like to do. I'm going to go ahead and multiply by negative 3 here to create an opposite negative 6. But again, I have to do that to every single term in the equation. Because I'm changing the first equation and not the second, I'm going to leave the second equation there and then write my new equation below that one so I can add those together. So the 2 times the negative 3 is negative 6x. There's my opposites. The negative 3 times the negative 5 is a positive 15. And then the negative 3 times the negative 4 is a positive 12. So by multiplying by the negative 3, I've created the opposites for my x variables, which when I add those together now will eliminate that x variable for me. So 6x minus 6x is 0, eliminated. Negative 10 plus 15 is 5. And then 12 minus 2 is 10. So the x has been eliminated. I can now solve for the y. So dividing by 5, the 5 is reduced to 1, leaving me 1 times y, which is y. The 5 reduces with the 10, leaving a 2. So the y part of the solution to the system is the number 2. To determine the x value, I can go back now and substitute into either my 2 original equations or the new equation that I created. I can substitute in the number 2 for y because I now know that y's value is 2. I'm going to go back to the first equation, the original first one, and substitute the y value into that one in order to create my equation. Sorry, I didn't mean that to come up. So going back to the first equation, so I have 2, and then I have x minus 5, and then I have my y value, which I now know is a 2, equals negative 4. I now have an equation with just the letter x, which means I can determine its value. So negative 5 times 2 is negative 10. And then adding the opposite of that negative 10 to isolate that x term. So I'm going to add 10 to both sides. That's going to leave me 2x. 10 minus 10 is 0. And then 10 minus 4 is 6. I then am going to divide by 2, which means I multiply by a half. So the 2 is reduced to 1, leaving me 1x, which is x. And this 2 reduces to that 6, making it 3, and 3 times 1 is 3. So the x term, or the x variable, is equal to 3. So the ordered pair 3, 2 is the solution to my system using the elimination method. Again, we're just creating opposites, and we're creating opposites by multiplying one equation by a number that creates opposites because there weren't opposites to begin with in my system. Looking at number 5, we again want to go through our steps, so we will check and make sure our equations are in standard form. They are. We will then look for opposite coefficients. The x coefficients, 2 and 4, are not opposites. The y coefficients, 2 and 4, are not opposites. So we're going to have to multiply at least one equation by a number that would create opposites. Now 4 is a multiple of 2, so I can multiply 2 by 2 to get 4, and if I did a negative 2, that would be negative 4, creating opposites. I could also do the same with the y values, multiplying the second equation by a negative 2 to create the opposite with the 4y. Either one, it doesn't matter. We're going to go ahead and multiply the first one, I think, here by a negative 2. So if I multiply this first number by negative 2, that's going to be the opposite of positive 4. And again, rules of algebra, properties of equality say it's okay as long as I multiply every term in the equation by that same number. Again, we're not going to be needing to move the second equation because we're just going to line up the new equation underneath that one. So we'll go ahead and multiply these out and write that down. So we have a negative 2 times this positive 2 gives me negative 4x. There's the opposites that I'm going to need. Negative 2 times this 4 gives me negative 8y. And then negative 2 times negative 4 is a positive 8. So multiplying by the negative 2, the top equation gives me opposite coefficients here for the x's. So I'm going to go ahead then now and add these equations together and eliminate the x variable. 4 minus 4x is 0. So then I have 2 and a negative 8, which is a negative 6. And then 16 plus 8 is 24. So the x has been eliminated from the equation, leaving me only the y, which now can be solved for. So I'm going to divide by negative 6, meaning I'm going to multiply by its reciprocal, which is 1 over negative 6, meaning the negative 6 and negative 6 in the numerator and denominator reduce to 1, leaving me a y. And then this is going to be a negative 1, and this will be 4. So positive times negative gives me negative 4. So the y value of my solution is negative 4. Now again, I can go back to either the two original equations that I have or the new equation I created, substitute in the negative 4 for the y, and determine what the x value is. So I'm going to go with this middle equation. I'm going to substitute into this one. So I'm going to rewrite that equation, and when I come to the letter y, I'm going to put in negative 4. That's going to give me 4x, and then I have 2, and then I have the y value, so I'm going to put in the negative 4 for the y, and equals 16. I now have an equation that just has a letter x, so I can determine its value. So 4x, 2 times negative 4 is negative 8. Leaving me this. I'm then going to isolate that x term by adding the opposite of this 8 to both sides. So that's 4x. 8 and negative 8 is 0. 16 and 8 is 24. Now that the x term is by itself, I can divide by that 4 or multiply by its reciprocal, which is what division is. And in doing that, these 4's reduce, leaving me 1. 1 times x is x. And then 4 goes into 24 6 times. So my x value of my solution to the system is 6. So the answer here is 6, negative 4 as a solution to the system using elimination. Looking at number 7 and going through our steps, we make sure the equations are in standard form. They are in standard form. We look for opposite coefficients. The 1 in front of the x and 5 are not opposites. The negative 6 in front of the negative 1 and the negative 1 are not opposites. So I'm going to have to go to step 2 and multiply one of these equations by a number that will create opposites. I can either multiply this first equation by a negative 5, thus creating a negative 5 and 5 for my x, or I could multiply this second equation by a negative 6, and that would give me a positive 6. So either way, I could multiply an equation by and create opposites. I'm not really sure which one's easiest for you, so I'm going to go ahead and just decide to multiply this first equation by a negative 5, making that the opposite of 5. So again, I'm going to have to do that to every term in the equation. Now, as I get over here, I notice I'm going to have to multiply 5 times 17, and that's kind of a big number. I don't have my calculator, so let's not do that, and let's go down to this equation, and let's multiply this one by -6 instead. Because if I multiply this -1 here by -6, this is going to be a +6. The y's will be opposites. Then I don't have to deal with such a large multiplication number there. Doesn't matter, but we'll just go ahead and do it that way. Now, because I'm changing the second equation and I'm going to want to add it to the first equation when I get done, I'm going to copy this first equation down here, so when I create my new equation I can line up the x and the y's, and then I'll easily add those together. So multiplying the -6 times the 5, then that's going to give me a -30x. The -6 times the -1 is going to give me +6y. There's my opposites. And then a -6 times 2 is a -12. So I now have my two equations. I do have opposite coefficients. My y's are opposites. So now I can go ahead and add these equations and eliminate that variable that has the opposite coefficients. So here I've got -30x, and x is going to give me -29x. The 6y and -6y equals 0, so the y is eliminated. And -17 and -12 is -29. So now I can go ahead and divide by that -29, which means I'm going to multiply by its reciprocal, because that's what division is. The -29 is reduced to a 1, leaving me 1 times x, which is x. And then this negative, and then this is a -1, so a negative over a negative is a positive. So the x value of my solution is the number 1. In order to determine the y value, I can go back to either of the two original equations or this third equation that I created, substitute in the value of x, and figure out what the value of y is. I'm going to, I'm going to go back to, let's say, this equation right here and substitute in my value. So copying this equation over and then substituting a 1 where I see the x, I'm going to get a x, which I know is 1, minus 6y is equal to -17. So I can add the opposite now of this 1 to each side to get the y value by itself. So 1 minus 1 is 0. I still have the negative in front of the 6y. -17 and -1 is a -18. So now the y value is by itself. So I can divide by its coefficient, which means I multiply by its reciprocal. So that's 1 over a -6. So this -6 with this -6 reduced to 1, leaving me y. And then this -6 is a -1. I'm dividing by -6, so it's a -3. And a negative over a negative is a positive, so this is a positive value of 3. So the solution to the system is the ordered pair 1, 3. For our last example here, we're going to continue through our steps and look for opposite coefficients, and if we don't have any, we'll create some. So we first make sure the equations are in standard form, which they are. We then look for opposite coefficients. 6 and -1 are not opposites. 4 and -1 are not opposites. So step 2, I'm going to need to multiply my equations by a number that creates opposites. Now, I could create opposites by multiplying this second equation by a 6, because that would give me a -6 here, which is the opposite of +6. I could also choose to multiply by 4 instead, because that would give me a -4 here, which is the opposite of +4. So given multiple opportunities or multiple choices, you just pick one that you want to do and go ahead and use that one. I'm going to go ahead and multiply by the 6 here, and so as long as I do that to every term, I should be okay. Now, because I'm changing this second equation and I'm going to have to add it to the original first equation, I'm going to copy that first equation down here so that when I create my new equation, I can line it up underneath this one and easily add them together. So I multiply the 6 times the -1, which is -6x. That gives me the opposites I wanted. 6 times -1 here is -6y. and then 6 times negative 2 here is negative 12. So having created my opposites, I go ahead and now add these equations together. So the 6x minus 6x will give me 0. I've got 4 and a negative 6x, which is giving me negative 2y. And then 16 minus 12 is positive 4. The x has been eliminated, the y is by itself, so I can divide by that negative 2 in order to find or determine the value of the y. So this negative 2 and that negative 2 reduced to 1, leaving me 1 times y, which is y. Both of these are divisible by 2, so that's going to be negative 1 in my denominator and a 2 here. That's 2 over negative 1, which is a negative 2. So the y part of my solution is a negative 2. And once again, I can go back to either the two originals or the new equation that I created to determine the value of x by substituting in this negative 2 for the y. I'm going to go ahead and go back to this second equation and substitute in my y value there. So I'm going to copy that equation, and when I come to the letter y, I'm going to put in a negative 2. So that's going to give me negative x minus, now here's where you have to be careful, that's the minus from the subtraction sign, and then I have to put in a negative 2. Okay, so don't accidentally shortcut this in a bad way by making this negative sign here, the subtraction sign, as part of your negative 2, because those are two different signs. Equals then negative 2. So I need to multiply this negative times a negative, which gives me a positive 2. I then am going to subtract this 2 from this side of the equation to get the letter x by itself. So that's going to give me negative x is equal to negative 4. I'm adding those together. Then I do have to get rid of or solve for x by multiplying by negative 1 to get rid of that negative sign that's in front. So this negative times a negative makes that positive. But as always, if we do it to one term, we have to do it to all of them. So negative 1 times negative 4 here is 4. So the x value of my solution is the number 4. So the solution to this system is the number, or is the ordered pair, excuse me, 4, negative 2. So that's elimination again when we have to create opposites by multiplying one equation by a number that gives us the opposites that we need to eliminate the variable.